I started as a PhD student here in Glasgow in the group that I now lead, and to have been through that entire process from being a student, joining a field, you know, that had a grand goal, you know, that we were working towards, to work right through the stages of designing detectors, helping, you know, build those, see the construction, the operation, you know, through, as I say, for me, about 25 years to get to the point of making that first detection is terrific. It really is amazing.
We now have unequivocal proof of the existence of gravitational waves. We've always believed they exist, but there isn't anything quite like detecting them to convince you of their reality. And this is a significant hurdle to overcome. Once you believe a thing is true, it's much easier to use it as a tool and explore the universe with these waves.
An electromagnetic spectrum. 2015 was International Year of Light. It was celebrating 150 years since James Clerk Maxwell did some key theoretical work which established the existence of the electromagnetic spectrum all the way from gamma rays and X-rays to radio waves. But this is a whole new spectrum altogether. The gravitational wave spectrum offers a different window in the universe.
It's absolutely fantastic. I mean, you know, you look back in the, you know, even the last few years, and you see, you know, you might say, well, what are other similar events? And clearly, you know, detection of a Higgs boson is a similarly, you know, amazing event in space and time, if I may say that.
I think we're amazingly fortunate that it did happen in that period right at the beginning of observations. You know, I think it would have been perfectly fair of the universe to wait until next year or something. But no, those stars chose a moment 1 billion years ago to collide, and not a week earlier.
It's unbelievably exciting. And it's not just we've discovered them. I mean, I've been waiting for this discovery for, 45 years. But it's not just that. It's the fact that for the first time we've observed black holes. There has been no direct observation of black holes up till this point.
It's not just about the detection, because I see detection as just the first step. It's fantastic. We've done it, okay, and that crosses a very steep barrier in the scientific community, that gravitational waves are detectable. Detection just means we can see them. Having seen one, what can you do with them?
We've had the goal of a first detection for such a long time now. We've achieved that goal, but now that that's come, a whole new set of challenges arise to decide what to do next. How are we going to best take the field forward? And so it's a very exciting, really exciting time in the field.